According to IEEE 979, a firewall is indeed required for separating oil-filled transformers that are rated for 13.8 kV or higher, especially when the oil quantity is 2100 liters or more. This requirement is in place to prevent the spread of fire from one transformer to another, ensuring the safety and operational integrity of the electrical infrastructure. The standard does not explicitly define a minimum height for the firewall relative to the bus ducts of the transformers. However, the primary function of the firewall is to prevent the propagation of fire and oil from one transformer to another, meaning the firewall must be designed and constructed to effectively contain and resist fire. Given the situation where the firewall is lower than the bus ducts, it is recommended to extend the firewall to be at least 1 foot above the bus ducts. This extension would provide a greater degree of protection against fire spread, as it would prevent flames and hot gases from easily bypassing the firewall and reaching the adjacent transformer. Fireproofing the I-beams of the bus ducts is not sufficient as a standalone fire protection measure. A firewall needs to be continuous and impervious to fire, thereby creating a physical barrier that prevents the spread of flames, hot gases, and potentially burning oil. Fireproofing the I-beams can offer some level of protection to the structural integrity of the bus ducts, but does not address the need to contain the fire itself. Considering these points, the following recommendations can be made to enhance the fire safety of the transformer installation. Firstly, extend the firewall to a height of at least 1 foot above the bus ducts to ensure that it effectively blocks the spread of fire. Secondly, ensure the continuity and fire resistance of the firewall, meaning that there should be no gaps or openings that could allow fire to pass through. This may involve sealing any penetrations in the firewall with fire-resistant materials. Thirdly, consider installing fire-rated doors or hatches in the firewall for maintenance access. These doors or hatches should be designed to automatically close and seal in the event of a fire, maintaining the integrity of the firewall. Fourthly, provide adequate spacing around the transformers for future maintenance and emergency response. Sufficient space allows personnel to safely access the transformers for routine maintenance and repairs, as well as providing room for firefighters to operate in the event of a fire. Regarding fire-quenching stones in the oil collection pit, it is important to ensure that the pit is adequately sized to contain the full oil discharge from the transformer. The fire-quenching stones can help to extinguish any oil fires that may occur, but they must be properly maintained to ensure their effectiveness. Furthermore, the proximity of the bus ducts, approximately 1 to 2 meters, raises concerns about potential fire spread between the two systems. If the bus ducts are not adequately protected, a fire involving one transformer could easily spread to the adjacent bus duct, potentially causing a cascading failure. Therefore, additional fire protection measures, such as fireproofing the bus ducts or installing a fire barrier between them, should be considered. To summarize, while the existing oil collection pit with fire-quenching stones provides a level of fire protection, it is crucial to ensure that the firewall meets the requirements of IEEE 979 and is properly designed and maintained to prevent the spread of fire. Extending the firewall above the bus ducts, ensuring its continuity and fire resistance, and providing adequate spacing around the transformers are all essential steps in mitigating the risk of fire. It's also important to consider the potential for fire spread between the bus ducts and implement additional fire protection measures as needed. Remember that fire protection is not just about containing a fire once it starts, but also about preventing it from spreading and causing further damage. By taking a proactive approach to fire safety, the risk of fire can be significantly reduced, protecting the electrical infrastructure and ensuring the safety of personnel. It is crucial to consider the specific requirements of the installation and to consult with qualified fire protection engineers to ensure that the fire protection measures are appropriate and effective. Factors such as the type of oil used in the transformers, the size and configuration of the transformers, and the surrounding environment should all be taken into account when designing the fire protection system. Furthermore, it is essential to regularly inspect and maintain the fire protection system to ensure that it is in good working order. This includes inspecting the firewall for any signs of damage or deterioration, testing the fire-rated doors or hatches to ensure that they close and seal properly, and maintaining the fire-quenching stones in the oil collection pit. It is also important to train personnel on the proper procedures for responding to fire, including how to operate the fire protection equipment and how to safely evacuate the area. Regular fire drills can help to ensure that personnel are prepared to respond effectively in the event of a fire. In addition to the measures discussed above, there are other fire protection technologies that could be considered for this application. For example, automatic fire suppression systems such as water mist systems or clean agent systems can be used to quickly extinguish a fire before it can spread. These systems are typically more expensive than passive fire protection measures such as firewalls, but they can provide a higher level of protection. Another option is to use fire-resistant transformer oil. These oils are designed to resist ignition and to burn more slowly than conventional transformer oils, reducing the risk of fire spread. However, fire-resistant oils are typically more expensive than conventional oils, and they may not be suitable for all applications. Ultimately, the choice of fire protection measures will depend on a variety of factors, including the specific requirements of the installation, the available budget, and the level of risk that is acceptable. It is important to carefully consider all of these factors before making a decision. It is also important to note that fire protection is not a one-time effort. It is an ongoing process that requires constant vigilance and attention to detail. By taking a proactive approach to fire safety and by regularly inspecting and maintaining the fire protection system, the risk of fire can be significantly reduced, protecting the electrical infrastructure and ensuring the safety of personnel. In addition to the recommendations already provided, it's worth emphasizing the importance of proper grounding and bonding of all electrical equipment. This is crucial for preventing electrical faults that could potentially lead to fires. Ensure that all grounding connections are secure and that the grounding system is regularly inspected and tested. Also, consider implementing a comprehensive fire prevention program that includes regular inspections, maintenance, and training. This program should be tailored to the specific hazards present at the transformer installation and should be regularly reviewed and updated to ensure its effectiveness. The program should also include procedures for reporting and investigating any fire incidents or near misses. Furthermore, it's advisable to consult with local fire codes and regulations to ensure that the transformer installation meets all applicable requirements. These codes may specify additional fire protection measures that are required for certain types of installations. It is also recommended to conduct a fire risk assessment to identify potential fire hazards and to evaluate the effectiveness of the existing fire protection measures. This assessment should be conducted by a qualified fire protection engineer and should be updated regularly. The fire risk assessment should consider factors such as the type and quantity of flammable materials present, the potential ignition sources, the layout of the installation, and the availability of fire suppression systems. Based on the findings of the fire risk assessment, additional fire protection measures may be recommended. In addition to the technical aspects of fire protection, it's also important to consider the human element. Ensure that all personnel working at the transformer installation are properly trained in fire safety procedures and are aware of the potential fire hazards. Provide regular fire safety training and drills to reinforce these procedures and to ensure that personnel are prepared to respond effectively in the event of a fire. Also, encourage personnel to report any potential fire hazards or unsafe conditions that they observe. By fostering a culture of safety and by empowering personnel to take ownership of fire safety, the risk of fire can be significantly reduced. It is also prudent to maintain detailed records of all fire protection activities, including inspections, maintenance, training, and fire incidents. These records can be valuable for identifying trends and patterns and for evaluating the effectiveness of the fire protection program. They can also be helpful in demonstrating compliance with fire codes and regulations. In summary, a comprehensive fire protection strategy for oil-filled transformers involves a multifaceted approach that encompasses passive fire protection measures such as firewalls, active fire protection measures such as fire suppression systems, proper grounding and bonding, a comprehensive fire prevention program, compliance with fire codes and regulations, a fire risk assessment, and a focus on the human element. By implementing these measures and by continuously monitoring and improving the fire protection system, the risk of fire can be significantly reduced, protecting the electrical infrastructure and ensuring the safety of personnel. The specific fire protection measures that are appropriate for a given transformer installation will depend on a variety of factors, including the size and configuration of the transformers, the type of oil used, the surrounding environment, and the applicable fire codes and regulations. It is essential to carefully consider all of these factors and to consult with qualified fire protection engineers to develop a fire protection strategy that is tailored to the specific needs of the installation. It is also important to remember that fire protection is an ongoing process that requires continuous vigilance and attention to detail. By taking a proactive approach to fire safety and by regularly inspecting and maintaining the fire protection system, the risk of fire can be significantly reduced, protecting the electrical infrastructure and ensuring the safety of personnel.